In this video, we're going to learn about how the periodic table is arranged. And you've got two main categories of elements, you know. You've got metals over here on the left side of the staircase, and you've got non-metals to the right. And then along the staircase, you got somewhat metals, some elements that are like, they're kind of metals, they're kind of non-metals. They got some properties of each. We'll look at them a little bit more specifically in a later slide, but those are called the metalloids right along the staircase. Anything that touches it, with the exception of aluminum, falls under that category. So what does it mean to be metallic? Well, metals, really, the big distinction between the metals and non-metals is that metals like to lose electrons. And we've learned that throughout the year when we're looking at ion formation and things like that. Non-metals like to gain them, ignoring the noble gases, but those are still non-metals. So the most metallic elements would be down here on the bottom left, and the most non-metallic would be up to the top right. And in here we have where that kind of changes over. Now, properties of some metals. One, they're lustrous, they're sheeny. They give a nice glow, they reflect light, photons that hit them. They're typically solids at room temperature with the exception of mercury. They're good conductors of heat and electricity, and they're malleable. You can mold them, you can make them into thin sheets. They're ductile, you can make them into wire. And they have great tensile strength. It's hard to pull them apart, you know. And they tend to lose electrons easily, like we said. Now, non-metals are the exact opposite. They don't conduct electricity. That's why when you have wires, you coat them with non-metal plastics. It prevents the electricity from going through your hands. Otherwise, it's like grabbing an open socket. Ow! Poor conductors of heat and electricity. They're not shiny, they're brittle. There are exceptions to that, of course, but this is for the most part. They can be various. Most of them are gases. Some are liquid. One's a liquid, bromine, and the rest are solids at room temperature. They're not malleable, they're not ductile, and they tend to gain electrons. So they're the exact opposite. And then you have the semi-metals, the metalloids, if you will. They have properties of both. If you look at silicon, probably the most important one we use in our world, used for computer chips, semiconductors, etc. It's shiny, but it's also brittle. If you hit it with a hammer, it's really fun, but it scatters all over the place. Not like a metal, but it conducts a little bit like a metal. It's shiny. Skipping that slide right there. When I say the main group elements, this is a term I'm going to use regularly from now on. What we're going to do is we're going to cut out the D block, and we're going to cut out the F block. Kind of like we do with grades here at Concord Carlisle. No one gets a D or an F, you know. Out of the main groups, we've got to know a few of them. We're going to learn about the alkaline metals, the alkaline earth metals. These are your transition metals in here. These are your pore metals. And here you have your non-metals. But we're going to learn specifically about the halogens right here. And we're going to learn about the noble gases as well. Now we'll look at some of the properties of each of these. So, alkaline metals are soft, they're silvery, and they're shiny. You can cut them with a butter knife. Not like most metals you think of, like a butter knife. They're highly reactive. You'll never find them alone in nature. You put them near water, they explode. You have to actually store them in mineral oil. Otherwise, on a muggy day, it's going to just burst into flames. That's scary, you know. It's so reactive, you're never going to find them alone. They only have one valence electron, one electron on their highest energy level. And as we'll learn later in the unit, they're also the largest elements within their period. They have the least effective nuclear charge, and they're rather large, which makes them lose that electron very easily, and that's why they're reactive. The next group, the alkaline earth metals, is like the little brother of the alkaline metals. They're a little bit less reactive, but you're still never going to find them in nature because they're too reactive. They're harder, they're more dense, they got higher melting points than the alkali metals, and they have two valence electrons. Then we have the transition metals, right in the middle. These are great conductors of electricity, and they're not really reactive for the most part. That's why we use them for things that need to withstand time and weathering and all that stuff. Some of them are used for coins. You know, you don't want that to break down. You don't want jewelry to. You don't want to be wearing a necklace and have it dissolve into your skin. You don't want that. You want stuff that's not reactive. And then we have the halogens. They're the most reactive nonmetals. Again, metals like to lose electrons. These like to gain them. They're very good at attracting electrons, and that makes them reactive as well. In fact, a lot of times they react with alkaline metals to form salts. Halo means salt. Gen means to generate or form. So halogen means salt forming. They usually exist as diatomic elements. Like, you're not going to find it alone. You're going to find it paired off with another one of itself or something else. They're all poisonous, which is terrible for you, and they all have 7 valence electrons, meaning they just need one more to satisfy that great octet rule. And the last group you need to know about is the noble gases. They're completely inert. The bigger ones, yeah, these ones can form some compounds, but for the most part, they don't react with anything. That's why it took so long to find them. They got happy complete outer shells with 8 electrons. What more do you need to know?